An HVAC service technician, there are certain tasks that are skipped or overlooked due to time constraints. Unfortunately, some extra steps are simply not deemed important. One of the most important tasks is the use of a nitrogen purge while brazing. On initial startup or when making repairs, a nitrogen purge is required to avoid subsequent component failure. This is an important step in building a reliable HVAC system. Why should we purge with nitrogen? Oxygen in the air combines with copper to form surface copper oxide. We see this on copper tubing as a light to dark brown discoloration. At high brazing temperatures, a heavy black oxide forms, called cupric oxide. After cooling, the oxide forms scale and flakes off over time. While mostly cosmetic on the tube exterior, inside the tube, the oxide flakes are carried by the refrigerant through the system. This contaminant can restrict flow through small orifices such as metering devices, reversing valves, TXVs, flow controls, or pilot valves. Important. If brazing is performed on a line set or system component and nitrogen is not used, component failures will result in a short period of time. This problem has long been an issue in brazing HVAC tubing. It has become more important with the change from HCFC refrigerants like R22 that use mineral oil to the new HFC refrigerants such as 410 using POE oil. Due to their polar nature, POE oils have a solvent effect and can scrub the copper tube walls. Oxide from tube walls and loose scale can circulate through the system. To prevent oxidation, flow dry nitrogen through the tube during brazing. Nitrogen is inert, non-reactive, and displaces the oxygen to prevent scale formation. Nitrogen is typically introduced into the system through the Schrader valve after removing the core or other system opening. Connect a hose or tube from the nitrogen cylinder to tubing or refrigerant port. The cylinder will be equipped with a regulator or flow control valve. There is no universal requirement for the delivery pressure setting, but the goal is to use low volume, low pressure to displace the oxygen. A suggested starting point is 1.5 to 2 psi. We recommend setting pressure until you feel a slight flow at the exit point on the back of your hand. Important. Initiate flow before heating and continue to flow nitrogen until the part has cooled. Avoid an excessive flow rate that builds pressure inside the tube. A high flow rate will tend to cool the tube, reducing brazing heat efficiency. Excess nitrogen pressure can build up inside the tube and reduce braze alloy penetration. The bigger the tubing, the more scaling would form. The purpose of the nitrogen is to displace any oxygen in the lines and minimize the formation of oxides. As the AC unit is put into service, these oxide flakes dislodge and can become trapped in the TXV, reversing valve, or metering orifice, leading to premature compressor failure. Manufacturers may not honor a component warranty if the failure is a result of improper brazing procedures. In our first demonstration, we brazed an 1.25 inch suction line without using nitrogen. You noticed after the joint cooled, when we tapped the tubing, some of the internal scale broke loose. The inside revealed excessive scaling. In our second example, we are brazing while using a nitrogen purge. When the joint is cooled, we'll cross-cut the second example to reveal the inside of the tubing and compare. This time, you'll notice no scaling formed inside the tubing. When we cross-cut the joint, you'll see the copper tubing looks brand new on the inside. When we place the two cutaways together, the difference is very obvious.
attention. If you work in air conditioning or refrigeration, you'll want to listen. Introducing the Zoom Lock braze-free fitting for copper tubes. You heard that correctly. Zoom Lock is braze-free, and when you can connect tubes without brazing, that changes everything. By eliminating the need for brazing, Zoom Lock lets you join copper tubes in less time, with less work, with less equipment, and even with less headache or experience than brazing requires. Just imagine life without brazing. Since you don't need a flame, you don't need gas. So you also don't need safety equipment, fire spotters, or hot work permits. Without brazing, almost anybody can join tubes with Zoom Lock, and you get more flexibility in where and when you can work. In fact, it's been proven that time and labor needed for tube joints can typically be reduced 40 to 50% when you don't need to braze. The Zoom Lock is patented technology based on the simple concept of crimping, and it's all very easy to do. Using the supplied tube cutter and crimp gauge, make sure the cut end of the tube is perpendicular. The tube also has to be properly deburred, because the Zoom Lock fitting has an O-ring inside, and sharp edges on a tube can damage it. Then just push the fitting onto the tube. A reference dimple in the Zoom Lock fitting helps assure the right insertion depth and a secure fit. Using the properly calibrated jaw, place the special crimping tool onto the fitting. Grooves in the jaws help you align it. Then press and hold the trigger on the tool until it completes its cycle. A special stamp displaying RLS will appear on the tube to show that the connection is right. It's that easy. No flames, no adhesives, and almost no time at all. The one-piece Zoom Lock fittings are reliably secure and leak-proof, so there's no compromise on performance. Zoom Lock fittings are also more repeatable than brazed joints.